Hello, this is Professor White. Today we will look at rational functions, their graphs, and inequalities involving rational functions. How you can solve them after you graph them, or with the test number method, and kind of figure things out that way. Okay, so let's get started. I'm going to break it down. We are going to look at finding vertical asymptotes for a rational function, horizontal asymptote, oblique asymptote, how do we graph them after we find all those asymptotes, and how can we solve inequalities after graphing. Alright, let's get started. So, a rational function looks like this. Usually you show it as r of x, and it is a division of two polynomials. So you can write like a rational function like this. X over x minus 1. Polynomial on top, polynomial at the bottom. You have a vertical asymptote for that kind of function when the denominator is 0. So x minus 1 is 0 when x equals 1. Here's your vertical asymptote. If you have more than 1, you just have more than 1. What about a horizontal asymptote? Again, if you have an r of x, you have a horizontal asymptote, or something that's like the behavior of that function at negative infinity and positive infinity. One thing, the vertical asymptote, so that means you have a vertical line, and I don't care what this r of x does, but when it gets kind of close to this, it never crosses, and that vertical line kind of guides it. And now on the other side, it does the same thing. Let's say it does this kind of stuff. Alright? So that's what a vertical asymptote means. Horizontal asymptote, and it doesn't cross that vertical asymptote. Okay? Horizontal asymptote on the other side, on the other hand, let's say you have a horizontal asymptote of that. That means the line. And I don't care what the function does, but in the middle, but at negative infinity, it gets very close to that. And it does all sorts of stuff. You may even cross it, okay? In the middle. But when it gets to be positive infinity, it approaches it. That is a horizontal asymptote. We'll talk about when you have a horizontal asymptote. For example, you have a horizontal asymptote when the degree of your denominator, so let's say my r of x is p of x over q of x. When the degree of q is greater than the degree of p. So in other words, you're divided by a big thing. When you divide something by a big number, you're approaching to 0. So you'll have a horizontal asymptote of 0. You get a horizontal asymptote when the degree of q equals the degree of p. Okay? Then your horizontal asymptote is the ratio of the leading coefficient of p over leading coefficient of q. Alright, well, let's look at something, and then you will see what I mean. I'll look at the vertical and horizontal asymptotes alone. So here's an example. R of x, let's say I have 2x minus 1 over 3x plus 6. Okay, I first factor it. 2x minus 1, 3x plus 2. Alright, let's look at the vertical asymptotes. When do I have a vertical asymptote? When the denominator is 0. When is the denominator 0? It is 0 when x equals negative 2. Here's my vertical asymptote. How about a horizontal asymptote? What did I say? I have a horizontal asymptote when the denominator's degree is bigger than the top or equal. Okay, well these are equal because this is 1 and 1. And when we have that, what is the horizontal asymptote? It is going to be the ratio of the leading coefficients. Leading coefficient on top is 2, leading coefficient at the bottom is 3. Okay, so I found the horizontal asymptote. What else can happen? I may have a slant asymptote. How does that work? Slant asymptote means your R of x will do stuff, but there will be a line here. I don't care what it is. So my R of x does crazy things, but then as it gets bigger and bigger, it behaves just like that line. You can cross it too. But then at the end, when it's very, 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 very small, it kind of behaves like that line. I mean, forget this, that, you know, you don't have a function. It will never do it that way. Maybe it will go something like that. Something like that. So that it passes the vertical line test. But, so make sure that you understand that. So let me draw that. Okay? Slant asymptote. That happens when, remember R of x was P of x over Q of x. When the degree of the top is 1 more than degree of bottom. Okay, it's going to be something like this. Let's say x squared plus x plus 3 divided by x. The top is 1 more than the bottom. Well, how do I find that slant asymptote? But it is 1 more, not 2. 1 more. So you have to do division, either synthetic division, or you're going to do the long division. Well, let's do the long division. Since this is a monomial, I don't have to do really long division. I just have to do this thing. So x squared divided by x, that's x. X divided by x, that's 1, plus 3 over x. So this thing is actually equal to that thing. And the part that doesn't have a denominator is your slant asymptote. Y equals x plus 1 is your slant asymptote. It's not this level of college algebra to look at like cubic asymptotes, quadratic asymptotes, those kind of things. This is what happens when the degree of the top is 2 more. You'll get like quadratic asymptote. What it's going to do is going to do crazy things in the middle, but at the end it's going to approach a parabola. Cubic asymptote, that means it's going to do crazy things in the middle, but you know, when it gets away from it, it's going to approach a cubic function. But at this level, we're just looking at the lines. It's doing crazy things in the middle, it's approaching a line at the ends. Okay, so, and we know how to find the slant asymptotes. What else can happen with R of x? You may also have holes. What do you mean by holes? Let's look at this. R of x, x minus 2, x squared minus 4. Always try to factor things before you do anything. That will make your life really simple. look what happens. When x is not 2, I can do this. What does that mean? My function is going to behave like this, 1 over x plus 2. However, it's going to have a hole at 2. Now it's going to have a vertical asymptote at x equals negative 2, because that's when this thing is 0. This is at negative 2, vertical asymptote. And actually this thing is shifted to the left of 1 over x. And if you look at 1 over x looks like this. Okay? So shifted to the level 1 over x will look like this. But is that all? No. What's going to happen at 2? Here's your 2 somewhere. It's going to have x cannot be 2. What does that mean? If you go look closer, you're going to have a big hole there. There's a hole in there, even though it looks like this. So this function is behaving like 1 over x plus 2 with a hole in it. Alright, very good. Let's look at this, for example, another hole. Somebody says, draw y equals 1 versus y equals x over x. It looks silly, but actually makes sense. Y equals 1 looks like this, right? Y equals x over x. You can do this. Yeah, you can do this. However, x cannot be 0. I know that. So this thing is going to behave just like 1. But what's going to happen at 0? You're going to have a big hole. Those are really good SAT questions. Alright? So, let's look at a problem, and we're going to graph it, and we're going to look at an inequality. So let's go to a new page. So let's say someone says graph. F of x equals x over x squared minus 1. Always factor x over x plus 1, x minus 1. Let's find the vertical asymptotes. Vertical asymptotes. When is the denominator 0? When x equals plus minus 1. Horizontal asymptotes. How do I find the horizontal asymptotes? What did I say? The bottom is bigger than the top. Horizontal asymptotes, y equals 0. So I already limited myself. To help myself out, I need to find some intercepts. Okay, well, how about some x-intercepts? How do you find an x-intercept? Set y to 0. What does that mean? This thing is 0 when x is 0. This goes through the origin. Look at this. It has to go through here. Is there any other y-intercepts? No. That's the only y and x-intercepts you got. Alright, so I have a vertical asymptote at negative 1, another one at positive 1, and I have a horizontal asymptote at 0. You can actually go and do some testings. I know that it's going to approach this, but I don't know how it's going to approach here or here. So put a negative number in there and see what happens. When I have a negative and a negative square, what's going to happen? You're going to end up with a negative number. Does that make sense? So it's not going to do this. I can take that out. It's going to do this. Since it's an asymptote at the vertical, it's going to go, you know, it's going to deviate. It's like, okay. Well, what's going to happen? It has to go through here. It can go through here 2 ways. I mean, actually more than 2 ways. It can do this. It can do this. It can do this. You can do that. Well, which one is it? So let's erase this stuff. You can test some things and look what's happening. Right here, just put something in there. When you put a number -0.5 or something in here, you're going to get a positive number. So it's going to have to come from here, since it cannot cross the vertical axis. When you put like positive 0.5, it's going to, when you plug that in, you're going to get a positive number. So it's going to have to come here. So this is what it's going to have to do. Alright, what will it do when you have a very, very large number? You're going to go, and you know that you're going to get a positive number, which is positive, and I'm looking at the leading coefficients. And since this is a vertical asymptote, it's going to have to do this. And since it's a horizontal asymptote, it's going to have to do that. Bingo! I drew this thing. It can be approximated, but now let's look at, once I draw it, can I go and solve something like this? Same problem. X over x plus 1, x minus 1. And I happen to have drawn the graph of it. What does that mean? When is this thing negative? Well, let's look at it. Where is it negative? That means below x-axis. Well, when is it negative? It is negative here and here. So how do I write that? Negative infinity to negative 1. I do not want negative 1 because it's a vertical asymptote. Union. Do I want 0? Well, I don't want 0 because it's less than 0. Union 0 to 1. I can look at the graph. That's it. Okay, how about this one? Solve x plus 1, x minus 1. When is it positive or 0? Okay, well, I have to think about that. That means above x-axis. All right, when is it above x-axis? It's going to be here and here. Okay, well, how do I write that? It's going to be negative 1 to 0, union, 1 to infinity. Well, now I'm going to pay attention to things. Okay, so negative 1. Do I want negative 1? It's a vertical asymptote. No. Parentheses. Do I want 0? Yes, because it has this equal thing, so I want 0. Union. Do I want 1? Well, I cannot have 1 because it's a vertical asymptote. Infinity. Can I put a bracket at infinity? Absolutely not. Infinities never take brackets. Now, did I have to draw this thing, or can I just test things? You can test things. Okay, so let's say somebody was asking, solve, and you don't want to draw a graph. X minus 1, x plus 2. When is this less than 0? Well, this is the best thing to do. Find the things that make the numerator, denominator 0. What are those things? X equals 0, x equals 1, x equals negative 2. Then you draw a number line. This is the test number method. You have the 0, you have the 1, and you have negative 2. Now you have a couple of regions. To see what the heck is going on here, pick like negative 5 or something and look. So you're going to have a negative number on top, negative number at the bottom, and a negative number. 3 negatives, so that means that's going to give you a negative. What happens to the right of negative 2? Between 0 and negative 2. So let's look at that. Put like negative 1 or something. So you're going to have a negative on top. you're going to have a -2, negative at the bottom, and then you're going to have a -1, a positive. Oh, look what happened. Negative, negative, positive, so it's going to be a positive. Now test it between 0 and 1. Put like 0.5 or something. You're going to get a positive on top. I'm just plugging it in here. And then negative at the bottom. And then a positive. So what are you going to have? You're going to end up with a negative. All right, one more. Just let's test another number like 5 or something. Put it in here. You're going to have a positive on top. And a positive here and positive here. So you're going to end up with a positive. So I know this rational function, I don't care what it does, but this rational function is going to be negative here and here. Now I'm going to pay attention to brackets and things. Now let's write it. Negative infinity to -2. Do I want -2? Absolutely not, even though this, because it's in the denominator. Union. So 0 to 1. Do I want 1? It's in the denominator. Do I want 0? Wait, 0. Yes, I do. That's on top, and you have equal. Here we go. Does that make sense? So you have 0. You want the 0. And okay, I think I got it. Well, what happens when I move things around? Let's say I have this. Solve x times x minus 1 over x plus 2. Where is this negative? Well, let's look at the original equation. What is different? That x minus 1 jumped up, okay? So I'm going to have the same kind of picture here. Okay, so you draw the same picture because those are the same factors. However, when I write it down, I put this in there and I now start paying attention to where the brackets and things are. Okay, so let me now let's look at this. Where are the brackets? Negative infinity never takes brackets. -2. Is it in the denominator? Yes. So it takes the parentheses. How about 0? Is it in the numerator? Yes. And I want this equal thing, so I'm going to have a 0, a bracket. How about 1? Oh, that's also on top. Watch. So it's going to be a bracket. So do you see the difference between this guy and this guy? So this changed when this thing jumped up. Okay? So pay attention to when you put parentheses and brackets. You can use the graphing or the test number method. Either way, you'll end up with the same answer. Thank you for watching.